Hello viewers, welcome to my channel. I'm Hasham Ali Khan. Last two videos I have explained you about the subject Operation Research OR. In the last two videos I have explained the meaning, definition, then application of Operation Research, evolution of Operation Research and advantages of this Operation Research subject. Now in this video I am going to start the topic that is called queuing theory. So first 2-3 videos I'm going to complete the theoretical aspect. Then we will start the problems on this topic of queuing theory. So watch the video till the end, because in examination you may get a theory question also apart from problems. So problems easily you can understand if you watch the theory. That's why theory is very important. So before starting the explanation of this queuing theory, take the screenshot of the points, then I'll explain all the points in detail. Now, queuing theory. So in our one will find the queues in our daily life in number of situations. In number of cases, we can see every day so many queues are there. Example, in the post office, in the banks, in restaurant, in patients waiting for a doctor at hospital, customers waiting at the barber shop for haircut, passengers waiting at railway station booking counter, students waiting at college fee counter. These are few examples where we find the queue in our day-to-day life. Apart from this, so many situations are there where we find the queues. The people are standing in a line to get some service. After getting the service, they will leave the system. So a waiting problem arises when either units requiring service or the facilities which are available for providing service stand idle. So in this queuing system, waiting time problem. So what is the waiting time problem? The customers are waiting in the queue. Till the time they will get the service, they have to stand idle. That is the waiting time for the customer. Sometimes the server, the counter which provides the service, will also remain idle if there are no customers at all. So the waiting time problem when either the customers are idle or sometimes facilities are idle. So our objective is to remove this idle time of both the customers and also the facilities. Now, the class of model applicable to the solution of these facilities and scheduling problems is called queuing theory. Ultimately, what is queuing theory? An analysis of this system. The system consists of the people standing in a line, forming the queue, waiting to get the service. After getting the service, leaving the system. Similarly, the server which provides the service will give the service to the customers. If there are no customers, the server will remain idle. So this situation, this process of analyzing is called queuing theory. Now queuing theory can be applied to many real life situations. Not only these few examples, but apart from that, there are a number of cases where this type of process will be there. And whenever this type of system is there, we can apply the queuing analysis. Now in recent years, queuing theory has been applied to business and industrial organization. Apart from these example of queues, this queuing theory is widely applied nowadays in business organization, in industrial concerns regarding the material handling units or maintenance system, inspection station or social service system such as supermarket, post office, repairing shop. So large number of areas are there where we apply this theory, queuing theory, to solve the problem, waiting problem of the customers and also for the server. So queuing theory suggests to management the ways and means queues may be adopted to reduce not only the size of the queue but also individual time. What is the purpose of studying this queuing theory? To understand the system, to understand the process, in order to reduce the idle time of the customers and also the idle time of the server. That is the main objective of queuing theory. So after listening this lecture, definitely you can be able to write in examination the theory part regarding what is queuing. Now, thus it is an important tool of managerial decision making for planning the ways that can serve the best to customers. Ultimate objective of the management is to serve the customers. The customers should be satisfied. The customers should not be dissatisfied from the system. So it is a managerial obligation that the business should serve the customers in a better way. The customers should not be dissatisfied. That is the main objective of this queuing theory. Now, characteristic of queuing system. So far, I have explained you about the meaning of queuing theory. Now, what are the characteristics, operating characteristics of queuing theory, queuing models? An analysis of given queuing system involves a study of different operating characteristics. You cannot be able to apply the techniques of queuing theory until and unless you are clear about the characteristic features. So queuing length, first characteristic feature is queuing length. The average number of customers in the queue waiting to get service. Queue length. The meaning of queue length is the average number of customers waiting in the queue. Average number of customers waiting in the queue to get the service. And the large queues may indicate that the service is poor. That means if the server is not providing the service fast, then what will happen? The length of the queue increases. When the length of the queue increases, when more number of customers are standing in the queue, it gives them dissatisfaction. More dissatisfaction about the business, about the system. So they are not satisfied. Now, system length. Queue length is different from the system length. Queue length means the number of customers standing in the queue to get the service. System length means the total number of customers in the whole system, those standing in the queue and also those who are getting the service at the counter. Simple example I'll give you. In a doctor's clinic, in a hospital, in a clinic, patients are coming and waiting in a lounge. One by one patient will go to the consultation room and get the service from the doctor. So if the average number of patients in the lounge are 5, suppose 5 patients are waiting in the lounge and 1 patient is getting the consultation from the doctor. So we can say the queue length is 5 because number of patients standing in the queue is 5. Whereas in the whole system, how many patients are there? 6. 5 are standing in the queue and 1 is getting the service. The system length consists of total number of customers, units in the whole system. Those who are standing in the queue and those who are getting the service. Now, what will happen if the system length is more? So here those waiting in the queue and those large values of these statistics imply if the queue length, if the queue system length, if the system length is more, that means more customers are there in the queue and also getting the service, it indicates what? It indicates congestion. Congestion at the place and possible customers dissatisfaction. Nobody wants to stay long in the queue for getting the service. So dissatisfaction among the customers and potential need for greater service capacity. Now there is a need to increase the server. Capacity should be increased so that the system length should be reduced. Waiting time in the queue. After joining the queue, a customer has to wait for some time before getting the service. So how much average time a customer stands in the queue before getting the service? That is called waiting time in the queue. So average time a customer has to wait in the queue to get the service. Long waiting times are directly related to customer dissatisfaction. If the average waiting time is more, this indicates that customers are dissatisfied and potential loss of future revenues. Once if a customer is dissatisfied, next time he will not come to get the service, he will go elsewhere. So in this way there is loss of revenue if the length of customer, if the waiting time of the queue is more, while very small waiting time may indicate too much service capacity. If in the business the average waiting time in the queue is very low, that means the facilities are more provided. Remember, the facilities if more provided, then what will happen? The cost will increase. The management has to see that cost should also not increase. We should not make more and more facilities. In that case, our cost will increase, whereas the length of the queue will decrease. The waiting time will decrease. So we have to consider that. Next one is total time in the system. That means how much time a customer spends in the whole system on an average. Just like example, when a patient comes to a doctor clinic, he will wait some 5 minutes or 10 minutes in the queue. Before getting the service of doctor, the patient is waiting 10 minutes in the queue. After that, he is having consultation with the doctor for 10 more minutes. So total time, how much he is spending in the whole system? 10 minutes waiting in the queue and 10 minutes getting the service. So total 20 minutes he's spending in the whole system. That is called total time in the system. The average time a customer spends in the system from entry in the queue and completion of service. From the time the customer enters into the system and the time when the customer leaves the system, how much time he spends in the whole system. Large value of these statistics are indicative of need to make adjustment in the capacity. If we find that the average time in the whole system is more, then the service should be fast. That means more service facilities should be provided. The people should not stand more in getting the service. Now, server idle time. Server idle time means the proportion of time during which the server is idle. When the server will be idle? When there are no customers at all in the system. Simple example, the doctor. The doctor spends 2 hours in his clinic. Out of 2 hours, let it be, suppose 30 minutes he is remaining idle. One and a half hour he is busy, all the patients are there. But half an hour he is completely idle. So out of 2 hours, half an hour he is idle. That means 25% of time. 25% of time the doctor is idle. Server is idle because there are no units in the whole system, no customers at all. That is called server idle time. The relative frequency with which the service system is idle. Idle time is directly related to cost. That means, however, reducing idle time may have adverse effects on other characteristics. If you reduce the idle time, definitely other problems will also arise. So these are the operating characteristic of a queuing model. In examination, you may get a theory question, explain about the operating characteristics of a queuing model. Then you should write first one, queue length, then system length, average number of customers in the queue, average number of customers in the whole system, then server idle time. These are the characteristics. Next comes the basic process, how this queuing system will be operated. So what is the process? The basic process assumed by most queuing model is that customer requiring service are generated over a period of time by an input service. See here, customers are generated over a period of time from the huge population. Example, we can see in the market one bank is there. In the whole market, so many people are moving from one place to another place. All the people are moving. But do all the people are coming to the bank? No. Only those customers who want the banking service, they are entering into the bank premises. Other people just moving away. So the process consists of, it's an input where the customer who want the service will come and join the system to get the service. Once he get the service, he will leave the system. These customers enter the queuing system and join the queue. At certain times, the member of the queue is selected for service by some rules known as service discipline. Service discipline means the rule through which the service will be provided. The different organization will provide the service through different methods. Example, in some organizations, they will provide the service on senior citizen basis. The service will be first provided to senior citizen persons. In some other areas, the service will be provided according to gender. Ladies first. The service will be provided first to ladies. Like this, some organizations, they will provide the service according to children. First they will provide the service to children. But most often, the service discipline is FIFO. First in, first out. First come, first served basis. That is called service discipline. So after joining the queue, he will get the service according to service discipline. The required service is then performed for the customer by the service mechanism, after which the customer will leave the system. This is the process of queuing system. Process of queuing system. Now, last one, single channel queuing model. Now, there are different types of queuing system. Multiple channel queuing system and single model queuing system. In single model queuing system, only one server facility is provided. In multiple channel, so many different servers are there. For example, if you go to a railway station, you can see there are different counters which provide the same service. You can purchase the ticket from first counter or second counter or third counter. So many different counters are there. It is called multiple channel queuing system. Whereas in other organizations, you can see only one channel is there. For example, if you go to bank, in a bank only one counter is there which provides the service to customer. It's so called a single channel. Similarly, in a college, the fee collection counter, only one fee collecting counter is there, single channel. So most of the channels are single channel only. Now, the most common case of queuing problems involve a single channel or single server. Only one person is providing the service. In this situation, arrivals form a single line to be served by a single station. All the customers are coming and standing in a single line because there is only a single server who provides service to all the customers. Then the following conditions are assumed to exist in this type of single channel. And I have seen in the previous examination question paper, they have given the theory question regarding explain single channel queuing model. So what I'm explaining now that is more important for writing the theory question. Now, what are the conditions for this single channel queuing model? The first conditions, arrivals are served on first come first served basis. That means the service discipline is first in first out. First come first served basis. So who comes later, they will get the service later. Those persons who come first, they will get the service first. That basis, and every arrival waits for the service regardless of the length of the queue. One more assumption of this single channel queuing model is, once a customer arrives and joins the queue, we assume that he will not renege the queue. He will not go away from the queue till he gets the service, irrespective of how long he has to wait. So after coming and joining the queue, he will get the service, he will take the service, and then only he will leave. That is the first assumption. Second, arrivals are independent of the preceding arrivals, but the average number of arrivals does not change over a period of time. Second assumption, there is no relationship between one arrival and the next arrival. For example, in a bank, one customer comes. After one customer, nearly 10-15 minutes, no customer are there, and then second customer comes after 10 minutes. Immediately within 2 minutes, third customer may come. Then fourth customer after 15 minutes. That means arrivals are completely independent of the preceding arrival. But we can calculate the average. For example, in 1 hour, suppose in 1 hour, 60 minutes, suppose 6 customers have arrived. So we can calculate, we can say on an average every 10 minutes one customer arrived. Because 60 minutes, 6 customers. So we can say every 10 minutes one customer has arrived. That is average. But in reality, we should not think that every 10 minutes one customer is arriving. No. On an average, we are saying that 10 customers, because there is no relationship between one customer arriving and the next customer arriving. Third one, arrivals are described by Poisson probability distribution and come from an infinite population. Now, there are different probability distributions like binomial, Poisson, or exponential, etc. Whenever there is uncertainty, we apply Poisson distribution. So, arrivals are completely uncertain. The bank cannot say that definitely 6 customers will arrive every hour. No. Some days it may happen during 1 hour nearly 10 customers, 20 customers are arriving. In another time, the whole 1 hour, no customers are arriving. So there is completely uncertainty about the arrivals. So that's why we have to assume the arrivals follow Poisson distribution law and come from an infinite population. The next one is service time varies from one customer to another, but the average service rate is known. See here. Arrivals are completely uncertain. There is no relationship between one arrival and another arrival. Similarly, the service rate will also differ from one service to another service. Example, in case of a doctor, when patient comes, the doctor has to diagnose, the doctor has to listen to the problems of the patient. It will take some time. So some patients are there to whom the doctor can give only 3 minutes suggestion. The diagnosis, the prescription, he can give only in 3 minutes. Whereas other patients, he may take 10 minutes. Some patients, 15 minutes. So time given to each patient will change, will differ. But we can calculate average. So during 1 hour, how many patients are served? That is called service rate. The average service rate may same, but every unit service will be different. That's the point. Service time occurs according to exponential probability distribution. Arrivals are assumed to follow Poisson probability distribution, whereas service is assumed to apply exponential probability distribution. Last one, service rate is faster than the arrival rate. One of the assumptions in this single channel queuing model is always the service rate is faster than the arrival rate. If service rate is slow, then definitely the length of the queue will increase infinitely. That's why always we assume that service rate will be higher than the arrival rate. That's all. So in this video, I have explained you about the meaning of the term queuing theory, then operating characteristics of the term queuing theory, and lastly, the single channel queuing model. And these concepts are very important for theory part. Still some more theory I have to explain that I'll continue in the next video. So if you're satisfied, give a like to the video, share my channel among your groups, among your friends, so that more students can watch the video and enhance the knowledge. Give your comments on these videos. Subscribe my channel if you have not yet subscribed, and buy the super thanks which is given below my video. Inshallah, we'll continue the next topic in the next video.